Hey, good morning. This has been Coutee, and welcome to another Questtec Tech Talk. As always, our goal here is to create a place for conversations from leading experts in their field and share their experiences on level applications and solutions. This morning, I'm going to talk with Owais Arshad, who's joined me before on here. He's our product manager for the magnetic level gauges and bridle applications. We had a site walk last week based on a field application, and we want to give you guys some insight into what we saw, what we took from it, and what we quoted as a solution. It's a field walk that I've been on multiple times throughout the year, so I thought it was important that we come on and talk about it. And as always, if you guys have any questions, feel free to reach out. If you guys have any topics you'd like to hear us cover, please let us know. Thanks again. Hey, good morning, and thank you for being here for another Questtec Tech Talk. I'm here with Owais Arshad again this morning.
Pleasure to be here as usual.
All right. Well, today we want to have a field focus on an MLG site walk that I brought Owais on, I believe it was last week.
Last week, yes.
Yeah, last week. Here local in Houston, and we got a call from the rep here, one of the reps that we work with, and had a customer that had some issues with a competitive product. The competitor's also here in Houston, but for whatever reason, they were having a hard time having anybody come on site or get some answers. So kind of a last-ditch effort, bring us in and see what we can do with it. Owais has a unique knowledge of transmitters, and they were involved in this, so I thought it was a good chance to get them out in the field. So we're on site working with I&E techs. Owais, let's kind of set the stage. We're in the I&E shop. What issues are they bringing up on the front end before we go out in the field, so we kind of know what we're looking at?
As usual, I mean, everything starts very vague. They just complain these things aren't working. And you start digging into it, and you start asking them, what's really going on here? They're saying, the transmitters aren't reading right. They're not matching the indicator of the MLG. They're not matching our DPs, and they're just reading off. And I'm like, it's kind of awkward, for a transmitter to do that because it can't change its settings on its own. So something weird has obviously transpired. And, being a mag guy, I always push mags, but definitely learned something by the end of this visit that we had. Yeah,
what were they telling us was the application was as far as in the field? And because we always try to do a little bit on the front end before we go out there to figure out if we can troubleshoot, before we even step in the field.
Yeah, these were knockout pots. So all the stuff that goes on in this refinery or plants are coming through this little skid package, and they're knocking out whatever the stuff that can be within this refinery, whatever liquids are going through. So the way the mag gauge, what we learned, the way the mag gauge was specified in this case was minimum SG, which is the way they're supposed to be, maximum operating pressure and maximum operating temp. So this particular vessel had two sets of DPs on it, and on the third tap was an MLG with a transmitter. The SG specified was 0.44. I guess they're trying to capture the lowest SG that can come through this this skid package, this piping.
All right.
So what does that mean with regards to a mag? So 0.44 is the minimum. So we're trying to ensure the float floats, but 0.44 isn't what's always coming through. And I think that's what we learned when we got on site. When we went to the actual unit, immediately you could see that the display was reading 4 inches. The display of the transmitter was reading 4 inches.
Right.
Roughly about 26%. Mm-hmm. The span of this thing was 16 inches. The DPs, which we didn't notice till later, were reading probably 28%.
28%.
Yeah, so what they had done is they had, number one, manipulated the transmitter to try to match percentage output of the DP, which was totally wrong. By the way, the liquid in the vessel, or at least the MLG indicator, was indicating 9 inches.
Right.
Not
almost
4.
60%.
Yeah. So it was, that's a drastic difference. So I told him, first and foremost, the most important thing here is to make the transmitter that's mounted right on the outside of your MLG to match the indicator of the MLG. That's first and foremost. That's how you know this thing is working right. First, So the next thing we learned was, the original package, every single one of these units was a bottom mount unit. So the electronics head was intended to be at the bottom. But when they got in field, for whatever reason, top mount worked better for them. So that started the trickle effect of having issues and not being able to solve them properly. They miscalibrated these things. They misconfigured them in the process of converting them to top mount. They felt like they got a few of them done correctly. I could kind of tell that, they were close, but not quite. But they were still getting the outputs they wanted, so they were happy. So this particular one was definitely off. It was just wrong.
Right.
So I told them, first and foremost, let's get these two things matching. I can definitely help with that. So, we did our calibration thing where we pulled the transmitter off the MLG, simulated level with a magnet at 4 and at 20 milliamps, 0 and 100%, which was a 16-inch span. As soon as we did that, mounted it back on, this thing begins to match exactly what the MLG is saying, which was about 9 inches. At that point, 9 inches of 16 inches is, over 60% here, or about 60%. And then problem is the DPs are
still reading that 28%.
Still reading that 28%. So what's the problem now? Well, here was our first initial look at what's really going on. Basic answer, the specific gravity of the liquid is not 0.44.
Not at that time.
Yeah, not at that time. So if you're at 0.6 or 0.8, this float is going to ride high. This float is going to show a much higher level on an indicator. It's flipping those flags. So it's riding high on the liquid, so it's also going to indicate on the flags. And only in comparison to a DP is it off. The other problem is the two DPs that were on the system, yes, they're matching as well. Why are they accurate and the mag is not? Well, here's something I learned about DPs recently. They can go into the DP and make them match. So there's a good chance someone went into the DP settings and adjusted for whatever the new SG coming in is and made the two now match.
Yeah.
You can't do that to a static product, a float that's designed for a particular SG. The swing is too large.
Right.
So there's really, being a mag guy, it really hurt to say this in the end, but I think we did offer them a solution. It just wasn't a mag, believe it or not. So
yeah, that's okay.
And that's what we ended up learning, right?
Your team Questtec.
So we've got we're Team Questtec. We got a versatile, arsenal of tools at our disposal. So we ended up.
I remember seeing, what was it, 0.44 to 0.96 was the swing or something like that?
Yeah, I mean, they could have that large of a swing, which is unheard of.
Right.
And that's what triggered me is like, you know what? Mag is not the best solution for an application like this where the swing in SG is so large.
Right. Now, there is a scenario where a mag wouldn't hurt them in this case, and I think that was one of the reasons why they had a mag in here that ended up giving them problems, is they had the same mag gauges in other areas of the plant, but the floats were not built for total level. They were built for interface, and it was either the interface of the 0.44 or the 0.96.
Yeah.
So you're not looking for total level. Your float's only going to ride when you have that 0.44 in there.
Yeah, when you have both liquids.
When you have both liquids in there.
So that was another issue they were having, and I think they caught on to that issue. But if we go back to the one that we were actually providing a solution on, the solution ends up being, and this could be where the industry kind of heads towards a lot when there's a swing in SG.
Right.
I think this is a very optimal solution. And you would ask me this 5 years ago, I wouldn't have thought to do that because it was a no-no for me. I was a mag guy. You're going to shove a mag in there, if you can. The solution was a bridle with a radar in it, and attached to the bridle was a large chamber glass track, our large chamber glass track product. So the glass track is going to give them their visual, and it's going to be the actual liquid that's direct sight reading, and the radar is going to be highly reliable, and it only cares about anything different than air. Right. So as soon as it sees level, it's going to tell you what the level in that vessel is. It does not care about the swing of SG. So it became an ideal option for them in that regards.
So bridle with the GWR, and then from the visual standpoint, for local visual, we can just come right off the side of it with a sight glass.
Exactly what we did. So we tried to give them exactly what they had in place. They had a visual from the MLG and a 4-20 from the magnetostrictive. So we gave them a visual from our glass track and a 4-20 from the radar. And it's going to be probably, in all honesty, 10 times more reliable. And then they're probably going to it's going to show that the DPs aren't accurate anymore. And they're going to find themselves adjusting their DPs a lot.
Yeah, I mean, the sight glass portion of it becomes what you see is what you get.
Yep.
There's no guesswork.
Yep.
It is what it is. Now, depending on the different medias and what they look like, I don't remember if we did reflex or transparent. Well, you have to be transparent in this case.
I did transparent in this case.
And that's because we have these different liquids. If it was a reflex gauge, again, for everyone listening, reflex only shows up as a black liquid no matter what it is, so you're only seeing total level. And that might be okay in some scenarios, but if they want to know the difference between when they have certain processes running through it, sight glass will give you a pretty clear visual. So again, it's not. I know it's not ideal for you to say we don't want to do the mag gauge. You do handle the bridles with us as well, so
it hurts a little, but yeah,
it's still in your scope.
The idea is to provide that solution, right?
Yeah. Okay. So good. I think, and the reason I wanted to get you on here and kind of talk through this one because it's not the first time I've seen it in the field. It's actually one of the more common things that we talk about when we have mag gauge and transmitter sight walks. Yeah.
I mean, knockout pots. See them all the time. So never thought to think that way until this, till we came across this in the manner we came across it.
Yeah, great. So for everybody listening, for our channel and, customers and users, if you're dealing with some knockout pots and you're having some issues with your magnetic gauges and the swings in SG, there is an issue. There is a potential solution out there, and we can work maybe with the mag gauge depending on what you're looking for. So just keep us in mind. And man, Owais, I appreciate it again. I always enjoy getting Owais in the field. I know you enjoy getting out of the office a little bit from time to time.
Love getting out of the office.
So if you guys need us, let us know. We're always ready to roll. Thanks again, Owais.
Anytime.